So we're going to start to talk about combining like terms, all right? So if you were to look at, let's see, your learning targets. The title of it is expressions, right? So every one of the learning targets that we're talking about in Unit 3, yes? What's that? Okay, can we get back to our own seats, please? Okay. So in each of these learning targets, you'll see the word expressions, right? So first we talked about what an expression is, how it's made up, what it's made from. It has some constants, it has some coefficients, it has all that good stuff. Then we talked about how to translate it. So now we're going to start to talk about simplifying it, okay? So simplifying is done by combining like things. So let's talk about the word combining. What does it mean to you? In regular world, not math world, and just regular world, combining means what, James? To merge things. Very good word. Or like to put them together. So put the markers down. If you have a marker wand, you're not going to be able to use markers. Okay, we're in 7th grade, no more marker wands. Combining means to put together. So go ahead underneath this. It means to put things together. What operation do we use in math to put things together, Nikolai? Addition, right? Okay. So adding is what we're going to do today. That's it. So all we're going to do is add, not subtract, multiply, or divide. We're just going to add, okay? And what are we going to add? We're going to add some things called like terms. So we need to talk about what like terms are. So let me show you using a little example here. So let's say I have these little centimeter cubes, okay, and I have this problem. You don't need your markers yet. I'll tell you when you need your colors. So you have 3 pink centimeter cubes, and I'm adding 2 pink centimeter cubes to it, right? Everybody agrees with that? 3 pink plus 2 pink means I have what? 5. If I combine them, and together I have 5 pink centimeter cubes. It's really as simple as that, okay? If I were to take, and let's do 1, 2, 3, 4, 5, let's say 6, green. Nikolai? Question? Okay, I didn't even finish the problem yet. Okay, so they do things by 5 pairs. So 5 plus 1 is 6. So this is 6 greens plus 3 greens gives me 9 greens if I put them together, right? Okay, so you're like, why is she showing us this? This is so simple. I understand that. It's very, very simple, okay? The reason we were able to add the 3 and the 2 up here is because right after that coefficient, they each had the same variable, right? Both had G's. That's why I was able to add those. So when they both have the same variable parts, we call these like terms. And like terms means you can add the coefficients when exactly what's after the variable is identical. Okay? So I could probably give you those all day and you'll be just fine, right? Okay? If I were to put a little spin on it and not use the cubes as part of it and just say 5x minus 8x, we're going back to integers, right? Remember that integers unit that we had? Okay, and here's the hard part. I just realized after doing this 3rd hour, I realized that you have multiplication on the brain, right? You have in your mind that a positive 5 times a negative 5 is a negative 25. And that's right? When you have one of each, it's negative. Okay? That's not the case with addition, is it? What if you had a negative 4 and a negative 3? It's a positive 12, right? That's not the case in addition. So I need you to kind of shift back over to those addition rules, okay? So if I had 5 positives and I needed to do, I would be doing the same problem as I would here, except with an x. So what do you think 5x minus 8x would be? Negative 3x, right? Okay? So this is actually a negative 3x. It's because on a number line, guys, if you were all the way over here at 5 and you needed to subtract 8, you would land over here, right? Or we're kind of at the point, we're almost 8th graders. We don't need to think about it as a number line. We just need to remember the rules. When the signs are different, you subtract and take the sign of the larger, right? The absolute value sign. So 8's larger than 5. It's negative. There were more negatives to start. Got it? So then what would negative 5x and a negative 8x give you? If I have 5 negative x's and 8 more negative x's, now I would have what? Negatives plus more negatives are negatives, right? So this is negative 13x, correct? Okay. What about negative 8a, positive 2a? What would that give you? If you have, yes, because if you have 8 negatives and 2 positives, do you see what I mean? So it's really subtract, take the sign of the larger. Watch. If I did the negative 2a here and the positive 8a here, what would my answer be now? Positive 6a. Are you guys seeing this? There's no way you're going to be able to do today's lesson and get them right if you cannot remember what those integer rules are. When the signs are different, subtract. When they're same, add. Okay? All right. That's a review. So now let's get back up to this pink-green business. So I know when I had both pinks, I could add them. Both greens, I could add them. What do you think happens when I have a little bit of both? Yep. Okay, so I want you to write this problem. 5p plus 2g and 5p plus 2g is not 7 anything. Roger. Wouldn't that be the answer? Yes. That would be your answer. Okay, listen, guys. If I asked you to combine this 5 pink with this, you can't tell me that that's 7p because you're not looking at 7 pink cubes, are you? You can't tell me it's 7g because you're not looking at 7 green cubes. So then somebody else wanted to know, why can't you just say 7pg? And that is not what you're going to do, because that would mean that one would represent a pink and a green. Maybe if you melted them and mushed them together and made a pink-green cube, but, okay, you can't do that, obviously. So this is your answer, because these are like terms right here, right? But these are not like terms, so we can call them unlike terms, okay? So they are not like terms because it's a different variable. There's not much more to it than that. Okay? I'll show you what you can do with that. If I were to just get rid of these centimeter cubes, if I said 5pg plus 2pg, now are they like terms? Yes. Now can I add those coefficients? Yes, because what's after the variable is identical, or what's after the coefficient rather. This is 7pg, okay? So, the reason that didn't work is because this was one variable and this was a different variable, okay? So, before we actually get into combining like terms, I need you to know what like terms are, okay? So, let's write this. Maybe pick one of your colors so it stands out. You can only add the coefficients when the variables are the same, identical. I'm going to say are identical. PG, okay? Somebody else brought up a really great question. What if it was 5pg plus 2gp? think about what you know about math. And what does PG mean? Nikolai?
It means 5 times P times G.
Yes. Another way to write this would be 5 times P times G. And it's kind of like saying 2 times 3 times 4. Okay, little side note. Let's do 2 times 3 first. We get 6, right? 6 times 4 is 24. Let's switch this order up a little bit. Let's do the 4 times the 2, then times the 3. That's 8. What's 8 times 3?
24.
So the order, and there's a property for this, right? Called the commutative property. And you know what? The order that you put those multiplications and additions in, it doesn't matter. So do you think I could add these?
Yes.
Yes, you can. You can add them because GP is the same as PG. And guess what? It technically wouldn't matter how you put your answer, but I will tell you this. All of my answers and all the answers you will see are in alphabetical order. So I would go with the G and then the P. Alphabetical order is kind of how it goes. Okay, so that was just a little side note there. So are we okay with like terms? All right, how about this one? This is kind of a weird. So you know how sometimes people say the color white isn't really a color? Like when you need to color something white, you don't really color it, you leave it blank, right? White crayons don't really do you any good unless it's on a piece of black construction paper, right, where it shows up. So I want you to pretend that that doesn't have a variable. You can almost barely even see it, right? So this problem is going to be 5p plus 2. Not 2a, not 2b, not 2w, just 2. So I'm asking you, do you think you have 7p? No. Do you think you have just 7? No. What do you have, Nikolai?
Unlike terms. 5p plus 2.
Yes, you have unlike terms. Find the variable, or find the coefficient. If what's after it's identical, you can add them. There's nothing there. So this answer is the problem. Hey, it's kind of nice when your answer is the problem, right? You don't really have to do much. Don't add that and tell me that's 7p, because it's not. I'm not looking at 7 pinks, right? Okay, so do you understand that that's a constant and that's that, okay? So now, what if I were to do this problem? How many pink things do you see here? And how many here? So this is just a pink plus a pink, right? So what is a pink plus a pink?
2.
Yes. Right? So there is a 1. I'm looking at them with my eyeballs. I see 2 pinks. All right? So then this is what's a little trickier. If you're following me, then you should be okay with this problem. So I just wrote 1p plus 1p equals 2p. Ready? So somebody tell me what 5y plus y, raise your hand, would equal. What's 5y plus y? Brian?
6y.
Good. Yep, 6y, because he knows there's a 1 there, and we learned that last learning target, right? Okay, are you following me? Are we good so far? So then what's x plus x? Angelina? 2x, yeah, 2x. So what's a plus a plus a plus a?
4a.
4a. Are you guys, you with me? Okay, pretty simple? All right. So that has you talking about what are like terms, okay? So now we need to start adding some like terms.